my god.
What? Be chill. I am chill. I'm at it.
Are you a nonchalant redhead?
What?
You're nonchalant.
Fine. How about this?
Are you a nonchalant redhead?
Okay. Tell her. She's gonna be like.
She's gonna take one look at me and go,
I
wait, you're a nonchalant town head.
What?
I relate.
Brendan.
Sometimes I feel like a rock.
Brendan.
Wait.
Brendan, just stay in the house.
I do. I really do.
Mr. Townsend, when are we getting a C chart?
Yes.
Yes, when are C charts not becoming a thing?
Oh, that's not gonna happen.
Brendan's not next to each other. Yes.
That sounds
You know how
like a
much
bad
work we'll
idea.
get done?
I just saw how much work he'd get done.
We work like physics?
I understand. I get it.
FD?
Yes, good job, Lola.
I'm gonna say FR and I realized that was part.
Work.
Oh, dang it. I used the bad zipper for my backpack.
Well, what the frick?
Yeah, the good zipper has.
Wait,
I
I thought we were supposed to finish it over there.
Oh.
Yeah, I do.
I guess not. Unless it's old though.
No, that's from the 8th.
Yeah,
My
okay.
backpack's broken the day before school.
Oh.
I spent all my midnight doing that, but then I went
Are you eating long enough?
That, the last question was
Yeah.
kind of hard.
The last one was weird.
I didn't get it.
Assume just immediately.
It doesn't seem to do it up there, and it looks like we're going over some portion.
This is number 34.
131 is in what?
It's in the homework box. If I don't have to turn it in, I'm not going to win.
Terrible. Yeah, but I didn't I mean, yeah, but. No, I didn't. Because I copied the solutions. Well, I got like, copying the solutions is re-explain this. I got 5/6 of the way through it, and then I hit the word block of R. Oh my god, I don't even know what to do there, so.
Hey, Joe, what's your tactic? No. I thought it was.
I have.
Not. Hey, Joe.
Guys, they're
Yes.
my answers.
Am I actually? Can I?
Yeah. There's not enough like seats, so like someone's gonna. So seriously, that would probably just sit at.
I'll bring my own.
Yeah, we also don't have enough time to read the board.
That was really mean. I saw that you said it.
I'm assuming ages. I've had different people in my car every day. Last first. But they keep changing it on me.
We still run like something.
More gas
You
chunks.
know about that? You know about that too?
And I got my oil change.
Oh, dang, you're good at
I
it.
know.
Not that bad. The last one.
Yeah, he just said like how I check questions. He said process, he was like, you don't have to answer, you just start doing it. I'm sure Number 6.
Garfield dog.
Oh, Odie, yeah.
You got like a spot.
He said it like I actually saw him.
He looked like two.
That's all right.
I get that reference. I get that reference.
He looks like uncanny.
I wonder why.
Garfield looks like uncanny.
You know how Maddie never showed me?
Lana.
For what?
I don't know. You never showed me this out.
Well, no, your hair is so cool. Yes, it is.
No, you played one song.
Alright, good morning guys. We need to, we're gonna spend, alright, Henry. Fourth time, fifth time, Henry. Put your phone up.
It's a.
No, it's not. I can see it. Okay, so we need to talk about derivative of exponential functions real quick, and then we're going to spend the rest of class on related rates, which is what we started talking about last class. So 35 won't take but just a second. Wait. 35 won't take but just a second to talk about, but I have not shown you this, so you've been off the hook on that until now. So it's not too much of an extension of what you already know, but I will preface this by saying that even though I think this is probably the easiest thing on your next test, most years it's one of the more missed topics. Not because it's tough, but because I think it's not tough. You guys don't worry about it, and then you don't look it over to review. But if you want to take the derivative of an exponential function, a to the x, this is how you take the derivative. And to show you how you've really been doing this the whole time, you just haven't thought about it, we've talked about the derivative of e to the x being e to the x quite a few times. But if we follow this format here, it's not really e to the x, it's e to the x times the natural log of the base, so times the natural log of e. But what is the natural log of e? So that's why we haven't been talking about it, because multiplying by 1 doesn't do anything. But if the base is not e, like if the base is 3, it starts off the same, you get one of the same things, but in this case, you better keep up with the natural log of 3, because the natural log of 3 is not 1, so not putting it there would be wrong. 7 to the x would be 7 to the x times the natural log of 7. So I feel like if you make this connection to e to the x that you already know, then it's not anything new that you're memorizing. It's just an extension of that. Of course, the only way we can make these questions harder is with the chain rule. So if you looked in your textbook, this is what it would show in the binder. You got some number to some power. You get some number to some power times the natural log of the base, like we did above. But if the derivative of this is not 1, you need to come back and multiply by its derivative. So they're just saying, make sure you don't forget about chain rule. So 8 to the x squared is going to create an 8 to the x squared times the natural log of the base, and then times the derivative of the inside, so times the 2x. 5x squared, what would be one part of my derivative? Okay, 5 to the 2x. And then somebody else, what would be another part of my derivative? Natural log of the base, which is 5. And then finally, the last part would need to be
2
times 2. Times the derivative of what's being plugged into 5 to the u. And number 6, I mean, this is about as hard as it could get, as crazy looking as it could get, but if you've got a number to some power, plus you an exponential function, the derivative is going to be the number to that power, just like e to the x creates an e to the x, but times the natural log of the base, and chain rule always applies, so make sure times 3x squared plus 5. Now this part right here, isn't this supposed to be 1? Is the natural log of 10 1? Why? So if your neighbor said the natural log of 10 is 1, what do you think that they might be getting mixed up? Right, the log of 10 is 1, because if the log is 10, it's talking about base 10. but natural log means base E. So this does not simplify to 1. So again, real easy. Takes about, I mean, we could do 20 more of these if you needed to, but you've seen all that you need to see. If I was you, I'd really focus in on that example, because if you understand it's times natural log of E, but that's why we don't write times 1, we don't talk about it, you can extend that to any of the others, and then it's not really anything new. Okay, so again, until last year when I really made a point to tell them that I thought that was probably there's 1 or 2 of these on your next test, and they are typically one of the more missed questions. Not because they're tough, but because students don't put any effort into them because they're not worried about them. I told last year's group that, and they did much better. So maybe you guys will also take heed to that one. Especially compared to related rates, which sometimes can take several steps. Those are much easier in comparison if you know what you need to do. Okay, so for our rest of class, we are going to look at related rates more. So last time was the first time I showed you related rates, and these just take more practice before you feel confident at them. So we're going to split in 2 different directions here. I'm going to take some questions from the circuit from last class, since I did not have help on all of those on the website, and you did not have time to finish it in class. You had to finish it up for homework. I suspect there's a couple that you might need help with, so I want to offer help on those. But if you are doing great on those and you put in the time and effort to be all the way caught up on those, you can go ahead and start on today's handout, which is 36. One thing I would note about 36, or 3 things I would note about 36, is the answers to the front page are on the bottom. The other questions past the first page are all previous AP questions, so they're multiple choice, and it gives you an idea of how difficult they expect you to be able to work these. Those answers are also on the back page. Now, of course, on the multiple choice questions, you will have to attach your work. You can't just magically know the answer to those without doing some work, so make sure you're showing your work there. And I would add that on the next to last page, question 6 is significantly harder, so I would save that one for the last. Yeah, Janine. Sure. So if you don't, no, you're good. So as people are asking questions from your homework that don't apply to you, just start 1 or 2 of those questions on today's handout 36. That way you're still making progress and moving forward, or getting help. Okay, and I know we did a bunch of these last time. Looks like we got to at least question 5 up on the board. But what other questions, when you went home and finished this up, did you struggle with?
Number 12.
The very last one? Okay, so first let's make sure we've got the same 12. Alright, now this isn't the best example of this, but just so you guys know that if you plan on majoring in business majors do have to have Calculus 1 now, at least at the U of A. Obviously, I don't know for every university and college, but the idea is, and we're going to talk more about this semester, if you own your own business, or if you're running a business for somebody else, you're interested in things like profit, revenue, and cost. And so even if you're not familiar with these, they tell us that profit is revenue minus cost. Now before the semester's over, we'll do things like find max and mins. And the reason calculus is required now for business majors is if you're running a business and you want to minimize cost, that has something to do with derivative. You want to maximize revenue, that also has something to do with derivatives. So again, this one's kind of a made-up question with just random numbers and all that kind of stuff, but there is a real important connection with profit, revenue, cost, calculus, and business that will apply to some of you all in your futures. Okay, so all that to say, if profit is revenue minus cost, here's revenue, 50x minus cost. Make sure you subtract all of this. So I distributed the negative to the cost. And all related rate questions are either a function of time or you're taking the derivative with respect to time. Either way. So if I take the derivative of profit with respect to time, that's going to be P prime. Normally, when I take the derivative of 50x, it's going to be 50, but that's only when I'm taking the derivative with respect to x. If I'm taking the derivative with respect to another variable, like time, you have to create an x prime. X squared, take the derivative. I'm taking the derivative with respect to time. X and t are not the same thing, so I need an x prime. Power rule, realize you're taking the derivative of x with respect to some other variable, so we need another x prime. This one, I would probably rewrite and do power rule, bring the power down, lower the power by 1, and once again, I'm taking the derivative of some x stuff with respect to time. If the variables don't match, you need an x prime. So you start plugging in all these numbers. This is 5.444. X prime is 0.05. 0.05. 8 times x times 0.05 plus.
When you took the first derivative, I think you made the first x cubed into an x squared.
Oh, you were right. Thank you. So that would make this 3x squared. So 3x squared. Okay, does that look better? Thank you. And you guys are figuring out that one of the things that's hard about calculus, when the questions are longer and take more steps than you're used to, just creates more opportunities for little careless mistakes like that. Everyone makes them, myself included. All you can do is be as careful as possible. So, all right, so now I have a solvable equation. It's kind of scary looking, but it only has one variable, x. And to solve this, there is some options. You would need a calculator. So most of the time, if I was solving this, I would solve it with graphing. I would graph this as one line in my calculator. I'd graph all of this as the second line in my calculator. And where they intersect would be the solutions to this equation. And that's fine. In fact, just in the next few weeks, we will do a circuit that's on calculator usage, and it has nothing to do with calculus other than it makes sure you know all the calculator stuff they expect you to be able to do. But even though you can do this with graphing, I want to finish this question by showing you one other thing that you may not be aware of. And once you're aware of it, if you practice it sometimes, you might be able to use it as a tool occasionally. So in your calculator, if you go to math and then go all the way to the bottom, it'll have something called equation or numeric solver. And if you go to that, your calculator is kind of programmed to solve really nasty equations like this. It's got some catches, it's not perfect, but you have to know how to use it. So I already have all this typed in from my classes yesterday asked about this one. So one side of your equation goes in for E1, the rest of your equation goes in for E2. If you go down, down, you go to the next screen. Our answer to this equation will be right here, but this is where if you don't practice it, you're not going to use it correctly when you need it. 5 is not the answer to this question. 5 might be the answer to the last time it asked me I use the equation solver. So well, first off, how many solutions does this equation have? What's the degree of our polynomial? 2. So quadratics have 2 solutions, or it could have one that repeats, or 2. So if you want the problem with the equation solver is it can't list out all the possibilities for you. So if there's more than one answer, it can only give you one answer. So if you want to put in a guess, like I think the answer is around -7, you can do that. But to get it to find the answer, you have to hit alpha enter. So notice on the enter button right above it in green it says solve. So hitting the green button alpha before hitting enter solves it, and it finds the answer nearest to what you had to guess. So I had -7 put in, so it found the first answer that was near -7. Well, this doesn't make sense because this would mean I'm selling negative whatever X represents. I'm selling negative items. That doesn't make sense. I want something positive. So maybe the answer is around 5. But 5 in for a guess, alpha enter, and it finds the answer closest to 5. Positive answer makes sense. 1.185. 1.185. Which loops back to the front, and this is the last question, so it was supposed to. So I'm not saying you have to be able to solve this equation with equation solver, but you do have to be able to solve that equation if you were given a calculator. So just make sure you either practice equation solver once in a while so that you can use it, because on a test or a quiz I can't help you use it. I can help you figure out how to use it beforehand, but not during an assessment. Or make sure you know how to figure out the solutions from graphing. And I would say that probably still, though, the most common mistake was every time we took the derivative of a variable that was not x, we needed that variable prime. I'm sorry, every time we took the derivative of something that was not t, because we're taking the derivative with respect to t, which was every variable. Okay, does anybody have anything else about number 12 while it's still there? Okay, what else from the circuit? 11? Okay, so if you didn't need help with 12, make sure that you didn't need help with 11 before you tune me back out here. 11 is probably the best one to ask, in my opinion, because there's one thing you have to assume about 11 that did not come up before you guys left last time. So let's kind of dive into it and then see what happens and how you're supposed to know what to do here. So conical paper drinking cup. So conical is just a fancy word for cone. This guy has a height of 6 and a radius of 2. How fast is the water level in the cup rising? So how is H changing? H prime is the point of the question. If water is being poured in at a rate of 1 cubic inch per second. Okay, so the per second tells me that this is a rate. How do I know what this is a rate of? Okay, how do you know it's volume though? Very good. Area units are always squared, volume units are always cubed, so that gives you an extra hint outside of the context of the question. And it needs to be at the instant when the water level is 2 inches deep, because depending on how deep it is, it's going to change the rate. So you realize, all right, we're talking about a cone. It's got something about volume. We probably need volume of a cone formula. This is probably the hardest one they expect you to memorize usually. Remember I showed you some tricks on how to figure it up in the moment though. And this is calculus, so you know you're going to take the derivative. It's related rate, so you know you're taking the derivative with respect to time. So this becomes v prime. 1/3 pi is just a number, so I can pull that out front and do it later. For these two, you need to see why, understand why you have to do product rule here, r squared times h. So you could take the derivative of r squared bring the power down, lower the power by 1, and remember that you're taking the derivative of r with h left alone, plus the derivative of h with r squared left alone. And you can do that. And sometimes that's what you're supposed to do. On today's handout 36, when you get to the multiple choice questions on the back, question 1, this is what you're supposed to do. And they give you enough information to do this. This time we don't have enough information. Sure, I know what h is, I know what b prime is, these are just numbers. I know I'm going to try to solve for h prime, so it's good that it's there. But notice they never tell me the radius of that time, nor do they tell me the radius, the rate the radius is changing. I just don't have enough information to do this. It's not that it's wrong, it's just not a good path. So the thing that happens with cone questions, again, it just didn't come up last time, which is why this is a great question. Notice that in a right cylinder cone like this, these sides are actually proportional. So if the radius is 2 and the height is 6, what that tells me is that if I triple the radius, it will give me the height. Because these have to be proportional. No matter what the height is, the radius is going to be 1/3 of it as this water level goes down. So that can be helpful because now that tells me that instead of saying r, I could say h cubed. Or, I'm sorry, h over 3. So instead of saying r, I could say h over 3. And then square this, times it by that gives us 1/27. H squared times h gives me h cubed. Now this is not true for all cones. It's true of this cone because of this relationship they gave me. This and this is how I came up with that and how I made this substitution. And now when you do the derivative, power rule, don't forget to do an h prime there, you are left with just stuff that you know. You know h is 2, h prime is what you want to know, and b prime is 1. So our answer, h prime, should come from 1 divided by a pi, divided by a 4, and multiplied by a 9. Which gave me 0.716. 0.716. So when I read this question, I had no idea that I needed to do that, and it's not a problem though, because you could see I did the derivative, I did the product rule, I had a ton of different variables, r's, r primes, h's, h primes, and there was no way I was going to find some of that information. And because I knew I was never going to find some of that information, I knew I either needed to change the h's into r's or the r's into h's. And that's where this highlighted part comes into play. That allows us to make that switch. So some questions just come out and say that to you. Like if you look at today's handout, question number 3, it says at the very end, assume r equals h. So for that question, you can just change out all the h's and the r's, or all the r's and the h's, and basically take the same approach as this question. But since we did not get to that last time you were here, I don't expect that you probably thought to try that as a tool. But now that you've seen it, next time you get stuck on a cone question, this only is an issue with cones, you might consider what I did there highlighted. Okay, is that enough? All right, anybody else for 11? Okay, somebody else had a question. Was it 11 or was it something different? Okay, go ahead.
Number 6.
6. Okay, I have 6 as being this one.
Yeah.
So what you got? Okay. Alright, spherical balloon is losing air at this rate. Notice how this is cubed. That tells me it's volume. Because it's got a time element, I know it's how volume is changing. what is the radius in centimeters when the radius is changing at 25 centimeters per second? Alright, so I know the shape is a balloon, something about volume, something about radius. So that's going to be a sphere. Now this is one you don't have to memorize the formula for. College Board always puts it in the questions if you need it, so I can also put it in all the questions if you need it. So you might have had to look at your notes for this one. But now derivative, derivative of v with respect to time would be v prime. This stuff, all of this is just numbers, so this is just power rule. Bring the 3 down, lower the power by 1, and then realize you're taking the derivative of r with respect to time. So that's your derivative. Start plugging in the stuff you know. Hope that there's only one thing you don't know, and hope that the thing you don't know is the thing that they're asking for. So for this question, it looks like our answer would come from taking 2500, dividing it by 4, dividing it by pi, dividing it by 25, and then square rooting both sides. My calculator says that comes out to be 2.821. So, don't lose any sleep if you had trouble with that because you didn't know the formula. That's not a problem. But okay, you good there? Okay, was anybody else going to ask about 6 while it's up? Okay, was there any others from the circuit? Okay. Try to give you plenty of time here. So I'm not asking you to turn this in today. Again, since I knew you should have had some questions on it, and I did not have enough help on the website for you to get it figured out yourself. That's why I offered some help and why I will wait till next class to take it up. But if you know, you missed one of those, if you had to ask about one of those questions, you should probably retry it again. Make sure that it is finished, because I do plan on taking it up next class. But then it sounds like you need to move on to assignment 36. So I verbalized this at the start of class, but since we're all here now, let's go ahead and say those directions again. Okay, so the front page, these are all related rate questions. Of course, vary in difficulty, but these are not AP questions. But the answers to the first 6 are on the bottom, so make sure that you're getting the same thing that they are before you move on. And if you're not, that's what you need to work with your neighbor on / ask me for help on. Once you get to page 2, all of these are multiple choice because these are actual questions from actual AP exams. So it shows you that some of these are not too bad and some of them can be a real pain, but you need to see how difficult they've asked in the past. So same thing, some of them are a little more straightforward than others. I mentioned this earlier, but I would probably do this question 6 last. It's kind of a pain. I don't know. Every year it's one that, even though I've worked this question probably 10 times in my life at this point, it's one I still kind of struggle through just because of how they go about it. So you'll know what I mean when you try it to see what I mean. But I would do that one at the very end after I had tried the rest. The answer to all the multiple choice questions are on the bottom of the back page. And I don't feel like I should have to say this, but this happens every year. If you just pick like D is B and 11 is E, If you don't put any work to those, then I can't give you full credit on the assignment. I need to see your work that makes you think it's B. I need to see the work that makes you think it's E. I'm not interested in what the answers are. I know what the answers are. So, one other thing that comes up quite a bit, just so you guys have seen it before and you're familiar with it. If you look at these answers, most of these answers don't have an asterisk next to them. So sometimes we do this. I didn't make this worksheet up, but like question 1 does not have an asterisk. That means it was a no calculator question. Question 2, no asterisk, means it was on the no calculator part of the AP exam. Question 9 and 10 have an asterisk, so those were on the calculator part of the AP exam, so you are allowed to use a calculator there. It doesn't mean you need one, but they allowed one for those 2 questions. So if you need a calculator on all of these questions, then you might need to be asking for some help to figure out what that connection is. But 9 and 10 should be the only 2 that, and just looking at 9 and 10, I can tell you a calculator doesn't even help you on those 2 questions. So, but they did allow a calculator there. All right, so last class we did, the whole time was to related rates, but it was also the first time you saw related rates. So you got an idea of taking the derivative with respect to time, talking about the geometry formulas, you saw the layout of the questions, you saw that Pythagorean theorem questions were the most common type. But again, one class period is not usually enough for everybody to feel great about related rates. So other than taking your homework questions and showing you the derivative of exponential functions, we've got a second full class towards related rates. Now you can notice down here on the homework, I don't expect you to get all the way through this worksheet by Friday. There's too many questions on here. Unless you're just really good at these, you're probably not going to get through all of these by Thursday. I am asking, you can see in homework here, to make sure that you are comfortable with at least 10 questions from this worksheet. So what I mean by that is you did the question, you got the right answer, and you feel good about it. So if you do question 7 but you get stuck on it, that doesn't count as one of your 10. If you try question 8 and you don't know how to start it, it doesn't count as one of your 10. I'm saying 10 questions that you actually finish, get the right answer to, and understand. If you can do 10 out of the 21, or not 21, 17, 10 out of the 17, then that will be good enough for Thursday. So, of course, I will offer help as well. So let me let you have some time to actually get a couple of these done for those of you that haven't started on it yet. And then I'll interrupt in just a bit to see if I can help with something.
Mr. Danson, where should I start learning this stuff? I'm just.
Well, we started talking about it last class. Did you watch the class recording for that yet?
Huh.
I mean, that's where I would start.
Okay.
Do you have some headphones?
The problem is I forgot my computer.
Oh, well, I can't help you if you forgot your computer. This is this is one of the handouts I'm going to give you on Friday. Maybe if you did some of it, it would help balance out your time so that you were still getting some stuff done that you're going to have to do anyway.
I had to skip this one. Oh, it was because you went over the one I was going. I just
Oh,
forgot
okay.
to go back to it.
That's fine. I was just curious why. You get the circuit from that you picked up from the 2 minutes last class.
Yeah, I've got it right here. Yeah, this.
You can use my notes to see if you can figure out some of it from that.
Okay.
Sign into it on.
Really?
Try not to.
Like this. But it makes sense. The derivative squared.
Oh. Right here. The radius, blah, 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 is increasing at a constant rate of 1 foot per second. So the radius is changing at 1 foot per second. You plugged in 1 for how area is changing. You should have plugged in 1 for how radius is
You
changing.
should start on the note.
Because area, that's what you're trying to solve for, how area is changing. So plug in a 1 there, and then your answer is 2 times 4 times pi, which would be 8 pi.
Okay. You just plug the 1 in.
Okay, I was gonna give a little bit more time than that, but some of y'all are flying through some of this. Does anyone need help with the first 2 questions, 1 or 2? Yeah. Number 2?
Yeah, I just want to learn. Still starting learning.
Gas is being pumped into a spherical balloon, so that's a sphere, at a rate of 8 cubic centimeters per second. So that is how volume is changing. So V prime. Find the rate that the radius is changing. So R prime, if the radius is 10 centimeters. So based on the shape, based on volume, based on radius, I have to make a guess about which geometry formula they want me to use. And this would be a volume of a sphere. Once again, this is the one you don't have to memorize. I would have put it on that geometry sheet from last class. Of course, you've got to take the derivative. So V becomes V prime. Over here, all of this is just numbers, so you're just doing power rule. Bring the 3 down, lower the power by 1, and then you need an R prime. Every time you take the derivative of something with respect to some other variable, you need that variable prime. So V with respect to t, V prime. R with respect to t, R prime. Okay, and then if we plug in our information, I knew this, I knew this, and I want to know that, then it looks like our answer should come from taking 8 divided by 400 pi, and this was a big thing last class. I think this happened to y'all as well. You got to be careful how you type this in. 8 over well, a couple things. 8 over 400 pi. Make sure that you don't type it in like this. Remember, your calculator does order of operations in not the way you intend. So if you're going to do that, do this. This is, second one's correct, first one's incorrect. But I was hesitating there because it doesn't really matter. We're trying to make it match up with the bottom. So 8 over 400 reduces to 1 over 50. And then that's how they got that as an answer. Okay. Any of the other questions, 1, 2, or, well, not 2, but 1 or 3, since it's still really early? Okay. All right, I'm not going to show 3 up here. You got the question in front of you. 3, gravel is falling in a conical pile. So conical is a fancy word for cone. Piling up at a rate of 100 cubic feet per minute. So that would be how the volume is changing. I know it's prime because it's got a time element. I know it's volume because the units are cubed. Find the rate that the height is changing when the height is 10 feet. Assume the coarseness of the gravel is such that R equals H. Okay, so again, one of the, I guess, scary things about related rates is how every question just seems different. You got to get past that. You got to focus on what is consistent. Identify the variables is consistent in every question. Drawing a picture usually helps. Every one of these questions, you either need to put this information on a picture or come up with a geometry formula. So, since this is a cone, that's the volume of a cone formula. It's got one base, so 1/3. Area of the base is pi r squared because the base is a circle times the height. And you can start to take the derivative here. But for this part, just make sure you're careful in doing product rule. Take the derivative of r squared with h left alone, and then the derivative of h with r squared left alone. I'm sorry?
Would you make r from h on this? This says r equals h.
This? Yeah. But I don't know how to use that yet.
Oh, okay.
So all I'm doing, I don't know which, I mean I do because I've worked this question, but you kind of have to get over the fact that you guys aren't going to know all the hurdles of the question when you start it. So volume formula, take the derivative, and if you've got all this information, great. Again, like I said, the first multiple choice question, you're going to have all this information, so you need it to look like this. But on this question, I am never going to figure out what r prime is. They don't give me the information, and I don't have enough information to figure this out. So it's not that that's the wrong derivative, it's just not a helpful derivative. So now I'll dig in deeper and think, okay, well I never used this, so this must be the key to help me out. So I could either replace all of the r's with h's, like this, since r equals h, or I could replace all the h's with r's, and ideally you put it in an educated guess about which one you're going to need. But if you think it's this one, that's fine to think it's that one, but as soon as you do the derivative you realize, wait, I don't know r prime, I'm never going to know r prime, and I don't even have the h prime I'm trying to solve for. So I should have changed them all to h's. So change all your r's and the h's. So that you're left with this statement, and then now we have all of this. I know that's 100, that's just a number, I know that's 10, and that's what I'm solving for. So divide both sides by 100 and both sides by pi, and that's where they're coming up with the 1 over pi answer. Again, this is unique to cones where you might have to change your h's and the r's or your r's and the h's. It's not going to come up with any other question type, only cones. But sometimes they'll just come out and say how they're related like that. So at least there's usually that hint there. When I started taking the derivative, these were just numbers. So I did the constant multiple rule, and I just did power rule. So when I brought the 3 down, 3 over 3 just became 1.
Oh, okay.
And then I lowered the power by 1. So when I did the derivative, doing the power rule made that 1/3 go away. Yep. Okay, let me give you a bit more time here. I thought you didn't have your computer.
I'm borrowing Sydney's.
Oh. That was nice of her.
As you walk further away, there's a point, someone similar needs to look the same size.
Yeah, but that's for the
Yeah, but that matters when the light angle changes.
Well, yeah, the shadows, I think everything except the height already. I mean, the heights are not true.
Yeah, I know. You know your heights aren't hidden.
Yeah, it's just.
No, I heard about this.
Still talking about
It just depends. If you change that to a decimal, you could use a calculator, but to try to figure out how they came up with that, you have to try to go. It's pretty tough. It can be done without a calculator.
Wait, so what would you do, like, you just do 50 squared, 150 squared, and then, like, for this, you just put the square root of whatever that was? Those two out together?
Of those two squared,
So they
yeah.
did
What is this side?
150.
And that's, well, 50 times 50 is not too bad. Because you can just do 50 times 10 times 5. And the other one's 150. Yeah, that's a little bit harder. It's hard to say. On the AP exam, they would probably show the calculator. Just because of the length of the question. Okay? Got the whole front page?
I keep getting like 160, like screen 17 over 17. I can't really figure out how to do it.
Oh yeah, that's the one I said is the hardest. I would
Like, I
say,
have an idea of how to do it.
I would save it for the end. I don't remember. I'm gonna have to
Like,
rework.
if they're gonna do it using like substitution, but I think.
Yeah, but that doesn't mean you should.
I need to do practice it on my own before I even try to help, because I know every year, just the lettering and the R and the Q's and P's and stuff.
Yeah, I just renamed it A, B, C.
Yeah, well, that's what I try to do too, but I still struggle with it, so. Just get that one and I'll come back and do it. Alan, you in trouble?
Let's listen to it. That's gonna be live. Some running it.
Oh.
Alan, you got letters? From where?
Texas A&M, Miami.
Yes, sir.
He's dropping me off.
Yes, sir. You got interest in Arkansas? It'll come.
Oh, wow, that's great.
You should do that.
I can't remember. Well, it was like he graduated
I did more stuff.
5 years ago, 4 years ago. I think he broke the state record for a mile.
We don't have any left.
Hudson Betts?
Hudson Betts or?
No, before Hudson.
Cameron Fisher.
It was probably Cameron.
No, it doesn't. It's not like
That last name doesn't ring a bell, but it's probably Cameron. But yeah, he was like super good, and Arkansas never gave him any interest at all.
Well, he actually moved back though, so.
Did he?
Because he went to, Princeton, but they're only 4 years school, and he had 5 years of education.
But I mean, he was like
You know it.
breaking records for the state, and Arkansas just never even
Yeah.
contacted him. Weird.
Arkansas is a type of school where when it comes to runners, they go without just to get them.
Mm.
I don't have them.
I don't know those things.
I do. I'm rolling it.
So for this one, the geometry formula you get is the derivative of. you have to set up a proportion. So your picture looks pretty good. So do you remember in geometry, sometimes you have like a small triangle within a big triangle?
Yeah.
Okay, so you can set up a proportion with the side piece. So like in your question, you know the first one's 2 meters and the thing is 6 meters, right?
8, yeah.
So, okay. So call this length X and call this length Y. And then you can set up a proportion of the sides. 2 to 8 equals X to X plus Y. That's the thing you want to take the derivative of.
Okay.
Because if I had room on my own whiteboard to do
You just don't erase it.
Freaky content.
You can erase this like weird little fat body, but.
So I'm just saying, you don't know either of these things. We call them X and Y. So 2 is to 8. Small triangle to this big triangle is to what to what?
X is the one. Oh, X. Oh, yeah. And
Okay.
4 I could do 2 over 6 is X over Y.
2 over 6? I thought you said it was 8.
It is, but if I wanted to, okay, whatever.
Yeah, so as long as you make a proportion, and then if you cross multiply, combine some like terms, maybe simplify it a little bit. Now when you do the derivative with respect to time, the rate of y equals 3 times the rate of x. They gave you this, and this is what you're trying to find.
Okay. Got it. Thank you.
What are you doing? What are you
You got work. Okay, it's been almost 15 minutes since I offered help on the board. So, first off, let me make sure, is there any questions from the front page before I offer help on other pages? Questions 1 through 6, any of those you have tried and it's not going well? Okay, then I know not everyone has made it to the next page, but what about the first 4 multiple choice questions? Yeah. Number 2. Okay, if you think you could benefit from paying attention to question 2, then please join us. Alright, question, I can't show it and work, so I'll do it over to the side. Question 2 says the sides of a rectangle, oh, the rectangle above, increase in such a way that z prime is 1, x prime is 3 times y prime. When x is 4 and y is 3, what is dx dt? Okay, so you got all that. So looking at our shape here, they said this is a rectangle, so I know this is a right angle. So even though it's a rectangle, that doesn't mean it's going to be area of a rectangle or perimeter of a rectangle. It could be this triangle. So, as I mentioned last class, related rates, the most common related rate is Pythagorean theorem. So, do power rule 3 times. Make sure you're creating an x prime, a y prime, and a z prime, because we're taking the derivative with respect to t, and x is not the same as t, y is not the same as t, z is not the same as t. So you need all of those. Feel free to divide everything by 2 to simplify it if you want. Start plugging in the stuff that you have to see where our roadblocks are going to be. Z prime is 1. I don't know Z. Y prime I don't know. Y is 3. X prime is what I'm trying to find, so I'm going to leave it alone. And X is 4. So if I'm trying to solve this for X prime, I can see I've got to do more work here because I can't solve this equation if it has 3 variables. I can only solve an equation if it has 1 variable. So I want to leave this alone, but I got to get creative with the Y prime and with the Z. I've got to figure out some way to represent those differently. So for the Y prime up here, I could divide both sides by 3, and Y prime is the same thing as X prime over 3. So these 3's cancel. 4x prime plus 1x prime would be 5x prime. And then for Z, well, I know this is 3, this is 4, so I could do Pythagorean theorem to find the hypotenuse, but 3, 4, 5 is the most common Pythagorean triple. So when this is 3 and this is 4, hypotenuse has to be 5. And then divide both sides by 5, and I would say the rate of change of X would need to be 1. So 1 is there, so it's probably good. But check the answer on the back, and for 2 they got B. That's okay, and that's where B was. Got that. So I would say one thing that you're probably doing that I don't do, like when I read that question, this hint is kind of confusing, so I just don't use it until I figure out what I need. I just do all the easy stuff, get down, realize I'm solving for this, I need those, and then at least I know I'm focused on what I actually need at that point. So sometimes you guys want to like try to predict how the whole question's going to go before you get going. So okay, is anybody else going to ask about multiple choice question 2? Have something else before I swipe it away? Okay, what about the first 5 multiple choice? Any others? The shadow one? Okay. Alright, multiple choice question 3. So all of my classes have asked about this one. This is a good one to ask because the thing that they're expecting you to remember from geometry, it's not just a formula that I can tell you to memorize. I think you'll recognize it once we get going here. But it's a good one to ask because I don't think it's as intuitive as some of the others. Okay, but we have a 2-meter person walking away from a light pole that is 8 meters. If the person is walking at a constant rate, that person's shadow, so the light's going to hit the top of their head. And then this is the shadow, of course. Their shadow is increasing at a rate of 4/9 meters per second. At what rate is the person walking? So that would represent this part of my picture. How many meters per second is he walking during that time? So we've got a right triangle here. We also have a right triangle here. So the big trick to this question, the thing that they are leaning on that you remember from a geometry class, is when you have a triangle within another triangle, these two are similar triangles, and a property of similar triangles are that the sides are proportional. So you can set up a proportion. You can put 2/8 as long as you follow the same pattern over here. So I did small triangle to big triangle. Now, unfortunately, we can't use these because these are lengths and these are rates. You can't mix and match those. So I'm going to have to temporarily say, I don't know this length, I'll call it X. And I don't know this length, I'll call it Y. But the big triangle length would be X plus Y. So, whereas most of these questions, you just start with the geometry formula we memorize, for this question, this is the geometry thing you have to start off as a base. So, making a proportion from those similar triangles. Now, why I like you guys to see this is because it emphasizes my point in that the calculus steps, the calculus concepts are usually not the hardest part of calculus. The hardest part of calculus is that they expect you to remember everything you've ever seen in other math classes. So, will this type of question come up again in this class? Probably once or twice, but you can see this was an AP question. They expected students to remember this from geometry. So we can't remember everything from every math class. That's not realistic. But we've got to be as good at the stuff that we know that they ask all the time, so that when we get questions like this, we aren't as worried or dependent on doing well on it. So anyway, we could cross multiply here. We could subtract 2x's from both sides. We could divide both sides by 3. You can do a bunch of simplifying, but at some point you need to take a derivative. Everything we're doing for almost the whole rest of the semester is about derivatives. So until you do a derivative, you're probably not on the right track. So the derivative of this with respect to time and the derivative of this with respect to time. X and y are not t, so the derivative of x needs an x prime. Y is not t, so taking the derivative of y needs a y prime. Well, I know this, and I want to know that. So our answer comes from 4/9 times 3, which would be 4/3. Choice D. And again, you could very likely just have a question like this on your AP exam, and some people are going to remember how to set up this proportion and some people aren't. That's why it's so important that you are prepared and ready to do the standard product rule question and the standard quotient rule question and the tackling the chain rule, all of that kind of stuff, so that you don't feel like you have to get this question right on the AP exam if it shows up. I'm sure most of you guys also know this because you're in other AP classes, but you typically, I can't say for all of your AP tests, I don't know about all your AP tests, but just so you know, you don't have to have a 60% on the AP exam to pass. You realize that, right? I think that the cut score changes from year to year, but typically, like, if you get 50%, you will at least get a 3. Some years you might even get a 4, getting 50%. So when you're practicing these AP questions, yeah, some of them are tough, but they balance it out by keeping the cut score pretty low. I think if you get like 70%, you get a 5. So as long as you're focused on growth, by the end of the year, that shouldn't be an issue for you.
Yeah, we do.
We're winning, we're winning state.
Mm-hmm.
I did number 5, and then I got the right answer, but I feel like I kind of just played around with the numbers until it worked.
Okay.
And so, but I like, I set the,
That's all I ever do.
okay, well, I set the circumference equal to the area. Is that what you did? The derivatives of both of them?
Okay, yes.
And then
So what's the derivative of area?
I got 2 pi r prime,
Good. What's the derivative of circumference?
2 pi r prime.
Okay.
And then I just divided 2 pi r prime out from both, and then there's just 1.
So you left with r equals 1?
Yeah. Is that all?
That's what you're supposed to do. Yep. See, that's the type of twist that AP likes to put on a question where it's a related rate, but it feels different than everything
I know, it
else.
doesn't feel right.
Yeah. Six times 3 is...
Oh, it would be squared is 625. Why are you putting it on? It's
That's my number 6. I just read.
Here you go, I just forgot to write a number.
Oh, okay. I just hate the PQR. It bugs me so much. Okay guys, we are down to about 8 minutes before you're dismissed here. So let me remind you where you need to be by Friday. So I know it's on the agenda under homework, so you can look it up later. But of these 17 questions on assignment 36, I want you to feel good about 10 of them. So stick with it long enough to feel good about 10. I've got practically every one of these worked out as individual videos on the website, so if you can't get to 10 on your own, you can lean on those to help you understand a couple more. And I expect that within you doing 6 of them, you're going to try some of them you get stuck on, and I will help you out with a few of them next class. But you need to be you need to be close to finished, and you need to have identified which some of the ones that you actually need help on. So you're welcome to keep on going with that until the dismissal bell, of course. But since we've only got 7 minutes left, I will also share our puzzle for the day, if you would rather do that. Okay, did y'all do this? Did y'all do all these? No? Okay, this one's 8 short puzzles instead of 1 big puzzle. I will tell you, number 7 has been by far the most unknown.
What station is that way?
Okay, so what's the first one?
Forget it.
Forget it. Okay. Number 2, I've heard 2 answers. What do you? Yeah, probably Jack in the Box. The other one I've heard is Blackjack. That kind of makes sense, I guess. What's number 3? Number 4. Back door. Yep. Number 5. Yeah. 6. Yep, we'll skip 7 because y'all don't know that one anyway. What about 8? 8's also a little harder. You might be too young. What? Right. The word's canceled and it's in the shape of a check. Like, you know, a check like you write for money. No. Alright, any guesses for 7? Huh? That's a pretty good guess. That's the best guess I've heard. Okay, what's the word say? Okay. What shape is the word in? Beeline. There you go. Beeline. That's what they were going for.
That's better.
B-log.